Okay, so let's look at an example of an application using the derivative. So it says the profit in thousands of dollars from an expenditure of X thousand dollars on advertising is given by P of X equals 1,000 plus 32X minus 2X squared. So we want to find the marginal profit at the following expenditures. In each case, decide whether the firm should increase the expenditures. Okay, so sometimes with word problems, you got to read through it a couple times. You need to start deciphering what it says. And so we're given a profit function, P of X. This is important. This is in thousands of dollars. And so our answer that we get back, we're going to times it by 1,000. And that would give us what the number would be. So the profit in thousands of dollars from the expenditure of X thousand dollars on advertising. So X equals the amount of money and thousands of dollars that we have used to advertise. Okay, and that's given by that profit. So find the marginal profit of the following expenditures. Marginal profit, this is finding the derivative. Of the profit function. So if it ever says find the marginal revenue, marginal cost, or this marginal profit, it's cluing you in to take the derivative of that function. So find the marginal profit at each following expenditures, and each case decide whether we should increase the expenditure. Okay, so at $8,000. So we want to find P prime of X. So we're looking at the limit. And so I know because of the example, I have multiple times that I'm plugging in different values of X. I want to first find the derivative of the profit function, and then we can use that derivative to answer any of the questions. So P prime of X, and the limit as H is approaching 0. P of X plus H minus P of X all over H. So plugging that in, we have the limit as H goes to 0. So this P of X plus H. We're going to go into our profit function, and wherever we see an X, we're going to rewrite it and put in X plus H. So we have 1,000, there's no X there, plus 32 times X. So X is going to be replaced with X plus H. Minus 2 times, again, we're going to plug in X plus H, quantity squared. And that is our function P of X plus H. Minus, well, we have to subtract off this whole function here. So we want to put parentheses or brackets around that. So minus the function of P of X, which was the 1,000 plus 32X minus 2X squared. And then we're putting it over each. So we got to do some algebra, expand by distributing, boiling things out, and combining like terms. So this is 1,000. So we have 1,000 plus, so it's distributing our 32, we have 32X plus 32H Unfortunately, I can't distribute this -2 yet because I haven't distributed out x plus h times x plus h. Really quickly, if we did that on the side, x plus h squared, it's not the same thing as x squared plus h squared. Do not do that. You have to rewrite what's inside the parentheses twice and then distribute. If you do that, you get x squared plus xh. Now distribute the h times x, so plus xh, h times h, so plus h squared. So this is x squared plus 2xh plus h squared. So maybe just writing it here so we can save some time. X squared plus 2xh plus h squared. And now let's distribute that -2 to each term in here. So if we do that, -2 times x squared is -2x squared. -2 times 2xh is -4xh. And -2 times our h squared is -2h squared. Now distributing our negative to our p of x function, we got -1000 minus 32x plus 2x squared. This is all over h. So notice things start cleaning up really nicely. Things start to cancel out. We have 1000 minus 1000 goes away. We have a 32x minus a 32x cancels. We have a minus 2x squared plus a 2x squared cancels. And so every term that we're left with in the numerator has a variable h. So we can factor that out. We have a 32h minus a 4xh minus a 2h squared left in the numerator. All over h. So pulling out our h in the numerator, one of the h's, we have 32 minus 4x minus 2h all over h. H is now cancel. If we did direct substitution, we will no longer get a indeterminate form. So go in and plug in 0 wherever you see an h. So we'd be left with 32 minus 4x minus 2 times 0, which is 0. So we just found the derivative function. P prime of x is 32 minus 4x. So now when it asked us what is the marginal profit at $8,000. Got to be careful here because back up here, it said that X was in thousands of dollars. So for this X equals $8,000 or $8,000, we're actually going to use X equals 8. And so we want to look at P prime of 8. So we're going to go back in wherever we see an X, we're going to replace it with 8. And notice we get 32 minus 4 times 8. Well, 4 times 8 is 32. And 32 minus 32 is 0. So if we spend $8,000, it's telling me that the profit function, that the rate of change when we spend $8,000, the rate of change of our profit is 0. So the question also asked, in each case, decide whether the firm should increase the expenditures. Talking about profit, we want our rate of change to increase for profit. And if we're getting the rate of change is 0, it probably would be a no. Don't increase the expenditure. So let's look at another one where it says, we already did most of the work, and it wants to know, what about if the expenditure was $6,000? So in this case, because our X values are in terms of thousand, in this case, we're going to use X is equal to 6. And so if we look at the derivative function and plug in 6, wherever we see an X, so we have 32 minus 4 times 6. So 32 minus 24. That's going to give us 8. Okay, so another thing to be careful here, because remember our profit was also in terms of thousands of dollars. So this would be saying we would have a profit of $8,000. This is greater than 0. So our profit is increasing. So in this case, we would want to increase. Yes. Let's just do one more. Let's say that it tells us that our expenditure for X was $20,000. Again, X is in terms of thousands. So we're going to look at X equals 20 instead. Plug it into our derivative, F prime of 20. I can already tell this is going to be a negative number. We have 32 minus 4 times 20. So we have 32 minus 80. So that is negative 48. So our expenditure, our profit, is decreasing. And this is in terms of thousands of dollars. $48,000. So no, we don't want to increase the expenditures. Okay, hold on, let me just